Well, here we are. So you should know by now that there is no chemistry regents. I've been teaching 40 years. The only other time that it got messed up like this is when somebody stole the answers to the regents in New York City and posted them online. So, here's the deal. You won't have a regents to take in June, but you will have my final exam. Okay? And this is actually like a win-win situation because it takes the stress off you in a stressful time, and I can teach a chapter that I don't really get to at the end called nuclear, which is phenomenal. So we have two phenomenal chapters to go over with great labs and great stories. So acid-base, which is going to be a little bit tough, we're going to start today, and then nuclear, which is my most favorite chapter of all. Now, I know some people, some of you guys are stressing out and you're going, well, if we don't have a regents at the end, then why do we have to keep on studying chemistry? Are you kidding me? You guys are above average taking regents chemistry in the first place. And most of you will probably take college chemistry. This is the foundation for college chemistry. This is very important for you to understand, because if you don't understand this, you'll get crushed in college chemistry. Okay? So you can either do one of two things. You can either, remember this, you can either rise to the occasion like nonpolar CO2 coming out of a polar liquid, or remember our last lab? Right there. You can fall down to the bottom and precipitate out like the iron 3 hydroxide and just do nothing. It's up to you. Self-discipline, like we talked about before. And most of you are doing a really good job with the questions and answers. So we're going to continue what we've been doing the last 3 weeks, only with a little twist. Next week, we have Zoom. So I'll be able to answer all your questions like face-to-face on Zoom on Monday, Wednesday, and Friday. I'll give you the times that Zoom will be on for me. Okay? Everybody's going to have to sign in either in the morning or in the afternoon, but then if you understand your stuff, you can get off. And some of you really will understand it, but that's how we're going to do some of the labs, some of the worksheets, and then I'm going to give you a packet with tests in it. Okay? So that's what's happening, and we are going to start with acid-base. All right? Okay, so here we go. New chapter. Acids, bases, and salts. And once again, like I start every chapter, bonding, bonding, bonding. You have to know your bonding to understand what's going on. So let's first start with that. KCl. That's a metal hooked to a non-metal. So a metal hooked to anything is going to be an ionic bond, like you already know. Okay? So here's KCl. The common name for a metal hooked to a non-metal or an ionic compound is salt. It looks like salt. But in this case, right here, this is solid. Now, ionic bond simply means this. Total transfer. So the metal transferred its electron to the chlorine. All right? So we have K plus ions and Cl minus ions. But the deal is, they're locked up into a crystal like you see here. So an ionic compound crystal, but they have positive and negative ions, but they're locked up. They can't move. Okay? They cannot move. So, this is older than I am. So when I test this with salt, it does not light the light bulb. What that means is solid ionic compounds do not conduct electricity. All right? I have to do something in order to make an ionic compound conduct electricity. So here's what I have to do. Here's distilled water. Water is this, H2O. It doesn't have a metal in it. Two nonmetals. It's not ionic. So it doesn't have ions locked in a crystal. So I wonder if regular water conducts electricity. Here we go. No. Regular water does not conduct electricity because it doesn't have any ions in it. H and O, they share electrons. They don't have ions. Whereas KCl, that's ions, but they're locked up. So how do I unlock the ions? Put a little bit of KCl in water. Okay, stir it up. Now what's going on is this. We no longer have an S there. We put it in water, so now we have to have KCl AQ. Now it's KCl aqueous, which means the solid ionic compound, the crystals, when we put it in water, it unlocked the crystals, so we have free ions. Now, let's see if it works. It works. So what's going on now is we have free ions because we put it in water. All right, the water broke the ionic compound up. We'll talk about that a little bit later on. But now what we have is we have a solution that has free ions in it. And a solution that has free ions in it is called an electrolyte solution. This was the first thing we did in September. So, if you put an ionic compound in water, it will probably be, it'll probably have free ions, so it'll probably be an electrolyte. But not all ionic compounds, when you put them in water, dissolve, like on reference table F. So, what we have is we've got an electrolyte. Now, so we're staying with this. The next thing is ionic compounds, metal hooked to something, like we said before. How do you name? Because we have to name all these. How do you name an ionic compound? Well, it's real easy. If it's a two-element ionic compound like KCl, you take the name of the first element, potassium, and the second element, you got to put it in "ide." So that is potassium chloride. Very easy. They're called binary compounds. Potassium chloride. All right? And we already went over naming, so hopefully you can name those. So that's a salt. A salt either has a metal in front and a nonmetal in back, metal in front, polyatomic ion in back, or metal in front and a hydrogen in back. Those are all ionic compounds. And remember the definition, total transfer. Total transfer is ionic compound. So that is a salt. All right? And you already know how to name salts. So let's go to the second one. Now, the second substance is NaOH. So the name, it's a metal hooked to a polyatomic ion. This polyatomic ion, OH-, is called hydroxide. So the name of this is sodium hydroxide. And, once again, metal hooked to a polyatomic ion, ionic bond. So it's got sodium ions locked together with hydroxide ions. Looks like this. This is sodium hydroxide. Crystal solid, right? Okay. Now, we already found out that ionic solids do not conduct electricity. So I'm not going to test this out because we already know that. But what's the big deal about this stuff? Now listen to me. Most metals, if they're hooked to OH, they are called bases. And this chapter is acid, base, and salt. So if you see an OH hooked to a metal, it's a base. But you know it's also an ionic compound. It has ions in there, but they're locked up. So my question is, what if we put that in water? What will happen? Okay, so here's my sodium hydroxide ionic compound solid crystal. I put several of these in water. So we'll swirl it around a little bit. Then we're going to take this, and then we're going to see what happens. So what do you know? You know this. When you put a base, remember a base is a metal hooked to OH. When you put a base in water, it dissolves and it makes something called an electrolyte, like we talked about before. And electrolytes conduct electricity because they have free ions in them. What freed the ions? The water freed the ions. Okay? So, you actually have a chart. Here's the chart. It says common bases. And it goes NaOH, AQ, KOH, AQ, CaOH2, AQ, NH3, AQ. So you have to put the base in water in order for it to conduct electricity. So that's a base. Bases are way easy to name because it's the name of the metal and then hydroxide. So this is sodium and then hydroxide. And what's the big deal between a base and a salt? They're both ionic compounds. They got ions locked in there, and they don't conduct electricity until we put water in them, and then they conduct because it releases the ions. Everybody got that? So, you know how to name salts. Bases, ridiculously easy to name. The name and then hydroxide at the end. Now, we come to this. This is a little different than the other two. This is called hydrogen chloride. I didn't say acid yet because that's in gas form. Guess what I have to do to make it an acid? What did I have to do to make a base conduct electricity? What did I have to do to make a salt conduct electricity? That's what I have to do to make an acid an acid. I have to put it in water. Once I put it in water, it becomes an acid. So watch. How do you know you got yourself a base? It's got something hooked to OH. That's a base. How do you know you got yourself an acid? Well, it usually has an H in front, and then it has AQ at the very end. So H in front and AQ. Now there's two types of acids. We'll get to that a little bit later on, but I'm going to show you this. Here's the second type of acid. I know I just said if you got an H in front hooked to another nonmetal, that's an acid, as long as it has AQ at the end. But look at this one. This doesn't have an H in front. It's got something weird at the end. It's got a Q at the end. So now, here's the deal. Whenever you see an H hooked to a nonmetal and an AQ at the end, it's an acid. And whenever you see a Q with an AQ at the end, that's an acid also. So there's two forms of acids. H in front, hooked to a nonmetal, and Q hooked to something, and then AQ at the end. Now, I told you bonding, bonding, bonding at the beginning. Look, salt, ionic bonds. Base, ionic bonds. Acid, there's no metal in it. So this is covalent. Covalent substances, covalent molecules do not have ions in them. So let's check out if they don't have ions in them, maybe they don't conduct electricity. Let's see. All right, so here is HCl, AQ. Let us see if HCl, an acid put in water, obviously it has to be put in water to be an acid, conducts. Wow. So something's going on, because HCl is not ionic. It doesn't have ions in it, but when I put it in water, it conducts electricity. So this is also considered an electrolyte because it conducts. But you don't know why it conducts, because there's no ions in there. It's very strange. So before I tell you why that conducts, we have to learn how to name acids. Okay? This is pretty easy. Not as easy as bases. Base is just the name of the front, like metal, and then hydroxide. Salts you already know how to name. So, you have a little sheet on how to name acids, but I'm going to do it up here. So, you already know binary means two. So a binary acid means H hooked to something else. So watch. We'll start with these. Binary acid, two-element acid. Now watch how we name it. If it's a binary acid, and remember, these have to have AQ at the end or they're not acids. An acid is not an acid unless it's put in water. Okay? Now, so a binary acid starts with this. Hydro. Okay? And it ends with this. So hydro something ic acid. So a binary acid starts with hydro and ends with ic. So watch. Hydrochloric, hydrobromic, hydroiodic, hydrosulfuric. You get it? So if it's binary, hydro in front and then ic. And the one we use the most, the one that we have in our stomachs, is this one. Hydrochloric. Remember, if it doesn't have AQ next to it, it's not an acid. All right? Now, if you look on your reference table, it gives you a list of about 8 different acids, and every single time they have something, they have an AQ next to it. So just remember, an acid is not an acid until it's put in water. Okay? We still don't know why it conducts electricity, but that's coming up later. We got to learn how to name the other acids. Okay, so that's how you name a binary acid. Hydro, chlor, hydrobrom, hydroiode, and then ic at the end. All right? Now we have something called ternary acids. We already learned how to name binary, hydro, something, ic. Ternary acids are way different. Ternary acids have H's in front, and then they have a polyatomic ion in the back. Okay, so watch. So, notice the H's in front and the polyatomic ions in back. And you have to remember this crazy little thing. You ready? If the polyatomic ion ends in 8, it's an ic acid. So it's 8 goes to ic. If the polyatomic ion ends in ite, it goes to us. So, 8 to ic, ite to us. That's what you got to remember. 8 to ic, ite to us. So the first one, H2SO4. All right? So that is the sulfate. So the name would be, since it's 8, sulfuric acid. This one is carbonate, carbonic acid. This one is nitrate, nitric acid. But this one is nitrite. So this would be nitrous acid. So you have to remember this. Ate to ic and ite to us. If it's a hydrogen hooked to a polyatomic ion. And for those of you taking New York State Regents, these are the acids that they will be talking about. So, hydrochloric, nitrous, nitric, sulfuric, sulfurous, phosphoric, carbonic, and acetic. Now, those are the acids we're going to be talking about and using in lab. So, that was a quick shot on acids, bases, and salts. Salts, ionic compound, won't conduct in a solid state. You put them in water, they got ions, so it will conduct. It's an electrolyte. Bases, metal to hydroxide. They won't conduct in solid, but if you put them in water, they conduct due to free ions. Now, salts and bases, when they break up in water, they dissociate. They break up, they dissociate, okay? That's bases and salts. But acids, you still don't know why they conduct electricity when you put them in water, but acids, since they don't have any ions in the system, they somehow break up, but it's not called dissociate. It's called they ionize. So, salts and bases dissociate. They break up in water and make electrolytes. Acids ionize in water and they make electrolytes also. Okay? So you have a huge list of how to name things. Now, your first couple questions. Here they are. And you should write these down on a piece of paper, and then once we get all the questions done, you take a picture and send it to me. The first question is this. You're going to write the formula for these two bases. Magnesium hydroxide, and aluminum hydroxide. The second question is going to be, these two bases have something in common. I want you to tell me this. I want you to tell me what those two bases are used for. Okay? So, formula magnesium hydroxide, formula aluminum hydroxide. Got to look on your phone. Got to figure out those two bases have something in common. What are these two bases used for? That's what you have to write down for your second question. Okay? All right. All right, we're going to talk about why acids, when you put them in water, why do they conduct electricity and turn into electrolytes when they don't have any ions like ionic compounds do? This is very heavy duty. You really have to pay attention. Goes back to bonding, of course. All right, so watch. So, I have HCl and H2O. It says HCl is a gas, so that is not an acid yet until you put it in water. So HCl gas is called hydrogen chloride. But, bonding, bonding, bonding. HCl, the Cl is stronger than the H. The Cl pulls the pair of electrons over closer to it. So it's a polar molecule. This is a polar covalent. And you all know, you better know, that water is also a polar covalent molecule. Remember, we call it a strong dipole. So when I put a polar in a polar, they will mix perfectly. Likes dissolve likes. Okay? All right, now, Watch. I'm going to do electron dots of these guys because that's the only way you will understand what's going on. So, there's Cl, and it's in group 17, so it has 7 valence electrons. Hydrogen, group 1, got 1. Now, I told you chlorine is more electronegative than hydrogen. That means chlorine's pulling hydrogen's only electron closer to it. So it looks like this. So the pair of electrons that they share is much closer to chlorine. So hydrogen is slightly positive and chlorine is slightly negative. All right, we got that so far? Okay, now let us electron dot water. O is the second most electronegative element on the whole periodic table. The only stronger element electronegative-wise is fluorine. Remember, I call fluorine the Rambo of all elements. It's the strongest electronegativity with 4.0. But oxygen is the second strongest. Group 16, 6 valence electrons. Hooked to 2 hydrogens. Now, like we said before, oxygen is really pulling hard on the electron from hydrogen. So the pair is very close to oxygen, which makes oxygen slightly negative and the hydrogens slightly positive. Now, this is the crazy part, so watch. When I bubble hydrogen chloride into water, here's what happens. The hydrogen chloride floats by the water molecule, and as it's floating by, the electronegativity from oxygen is so strong that it actually rips this hydrogen away from the chlorine. So only the H+, so that oxygen rips this right off and it sits right here. Do you remember what kind of bond? When one element shares its unshared pair of electrons with something that needs it? That's called a coordinate covalent bond. Now, this is very difficult to understand, but this HCl is floating by. Remember, hydrogen's electron is close to chlorine. So when HCl floats by a water molecule, the O is so strong, when the HCl floats by, it rips off the H+. But what the heck is an H+? Well, you watch. An H+, what makes up an H+? Well, if the oxygen from water just ripped off the H+, you know that H+ only had 1 electron and it's still hooked to the chlorine. So H+ has this. Got no electrons. It's one of the only elements that doesn't have this. Got no neutrons. Then what is an H+? Well, an H+ is simply this. It's a bare proton. Bare proton means and H plus is just a proton. So it's a positive proton. Now, H plus, it's not happy. It can't float around by itself in water. Remember, every element on the periodic table wants to look like group 18, the noble gases, electron-wise. So if H plus has no electrons, what noble gas electron configuration would be closest to H plus? Helium. So what does H plus want to have to become stable? It wants 2 electrons to become stable. And you just saw the H plus, when it floated by, bang, those are the 2 electrons that it saw on the very electronegative oxygen, and it stuck right to it. Everybody got that? Now, since that H plus got ripped off the Cl minus, I'm going to show you what it looks like. So we had this. We had this. Now, once that H plus got ripped off by the water, now here's what we have on the other side. H3O plus Cl minus. Look what we got on the other side when I bubbled hydrogen chloride into water. We got ions. So now you know why, when you put an acid in water, why it conducts electricity. Because the water rips off the H plus, and all of a sudden it turns into H3O plus and Cl minus. So now the acid has ionized. And once the acid ionizes, it's got ions in the solution, it conducts electricity, and it's considered an electrolyte. Everybody understand that? You're going to have a bunch of questions on that. So, that's kind of what happens. So the next thing we're going to go over will be the first guy that figured out something like this. He was a Swedish chemist. His name was Arrhenius. So now this is the equation, but I'm going to do electron dot-wise to show you again what's going on. This is so important for you to understand. Okay, that's what we had before. The HCl, remember, chlorine's kind of electronegative, and it's pulling the hydrogen's electron closer to it. So when HCl is bubbled through water, when that HCl floats over the water molecule, the oxygen is so strong, it rips off the H plus. Now, why is the H plus happy that oxygen has ripped it off? Because once H plus jumps on top, it's got the 2 electrons. It's happy. Now over here, here's what it looks like. So this is H3O plus. And this is a polar bond, unequal sharing, polar bond, unequal sharing. Oh, look. That is a coordinate covalent bond. So that's H3O plus. Now the other thing, the only other thing that's left is that chlorine. Now watch. That is chlorine, and watch. 1, 2. But it has hydrogen's electron. So chlorine now is happy. It's got 8 in the outside shell, but it has 1 more electron, so it's a negative ion. So it's H3O plus Cl minus, like it is up there. Okay? You got to go over this a couple times to understand this equation, but this is incredibly important equation. A whole bunch of acid-base is based on this thing right here. All right? So, when an acid is put in water, the water steals the H plus from the whatever, like the hydrogen chloride, and it turns into H3O plus, which is called the hydronium ion, and it leaves that Cl minus. So I had no ions at all, and now when you put an acid in water, it ionized. Now some acids ionize hugely, which means they're really strong because they got a ton of hydronium ions in them. And some acids just ionize a little bit, which means they don't have very many H3O pluses and they're very weak. Okay? So, that is the first lecture on naming acid bases and salts and how come acids conduct electricity and become electrolytes. The next little video will be on the definition of an acid by Arrhenius, and then something crazy called alternate acid-base pairs, which you already see right here. All right? So, for the first thing, all you have to do today is write magnesium hydroxide, write aluminum hydroxide, and figure out what the use. They have similar uses. You got to figure out what they're used for. That's the first one. All right.